All right. Hey, everybody. It's Derek Elliott. Today, I'm going to do a Model Y hot weather test. I live in Orinda, California. I'll be driving to Merced, California, and back. A little more on that. So how do we get here? This was a challenge kind of posted on Twitter by this Facts Chaser guy. I assume he's just part of this Tesla Q crowd or anti-Tesla guys, and post some like pretty, unsupportable or unsupported claims about Tesla and it not being good and this and that. And so this is how we got here. So he's claiming that the Model Y long range will deliver no more than 125 miles in the dead of winter on a full charge, or 160 miles in the summer with AC on. And I said, look, that's just patently false, and I could show you, but did not believe me. So what I did is a control test last November along the same route, and those postings were in a previous video. But the long and the short of it is, did the 250-mile round trip no problem with about 40 miles to spare. So we'll see how we do today. But just to kind of set the conditions, he's saying the car will not go more than 160 miles in summer with the AC on and temperatures above 85 degrees. So the test, I'm going to drive 125 miles, greater than 160 miles in the summer when it's greater than 85 degrees out. I'll have a full charge on the car. Highway speed. So what I'm going to do is just the speed limit. Some portions are 65, some portions are 70. We can average those out, but it's safe to assume between 65 and 70 will be the entirety of the trip. And I'm just going to do the speed limit. The route, I'm going to go from Orinda, California to South Merced. It's 125 miles each way. The reason I like doing the same route twice, or basically with a turnaround point, is it nulls out any effects of the wind. So for example, if there's a tailwind on my way down, that'll turn into a headwind on my way back. Any sort of elevation change on the way down will be nulled out by an elevation change on the way back, that sort of idea. And again, other than the small portion it's going to take to get from my house to the freeway on-ramp, this thing is going to be 95% highway. So the conditions and the method, this is a 2022 Model Y long range. I do have the induction wheel, so notionally that gives me a 12-mile hit. Takes the best case scenario advertised range from 330 miles down to 318 miles. But keep in mind, at this point, the car is now over a year and a half old. So I've got 23,000 miles on the odometer. Again, the car at this point, you call it probably 18, 19 months old, something like that. So there is a calendar life degradation that happens to the battery. Most of that is in the first year or so. So this is now at pretty close to steady state. So I would expect somewhere 5 to 7% is probably off the initial advertised range. And again, I'm just going to do the speed limit. That speed limit is an important caveat because drag increases exponentially with speed. So certainly the ranges I'm going to get today at 65 to 70 miles an hour are going to be higher than the range you would get if you were to do 75, 80, 85 miles an hour, something like that. But what's certainly going to affect us today is the temperature. So I'm going to say the average temperature here, predicting it to be about 95 degrees. It's 85 already in Orinda, and this is going to be the lowest temperature we're going to encounter today. So I expect it to be about 105 in Merced. It says the peak heat's 107. So I'm going to round that down to 105 just to kind of keep the math simple, and then split the difference between 85 and 105 and call it 95 degrees is average temperature today. Reality, it's going to be a little bit higher than that. But again, I'm trying to skew every part of this test to say, hey, this is real world and there's no cheating going on here. And the cabin temperature, I'm just going to keep comfortable, 70 degrees, maybe 72, whatever is going to be comfortable for the day. So my predictions, I predict I'm not going to need to charge. So even though as when I get in the car, it's probably going to say I've got 300-ish miles, maybe 310. I know that it's going to be something less than that. I concede that point because these are real world driving conditions. I'm going to be going highway speeds and it's very hot. So I do expect to take a hit. What kind of hit do I expect? I think about a 10% hit to range. That would take me up to about 275 watt hours per mile, or 68 kilowatt hours used on a 250 mile loop. So I'm anticipating I'm going to come back, pull into my garage with something like 25 miles remaining on the car. And just in case something goes wrong, there are 14 supercharger locations on the way. So if something starts to go awry, I'm just going to stop and charge and then continue the trip. But that's all I got for now, and I'll check back in once I'm in the car. All right, hey, what's up? We're about to start the drive here. So just to show you kind of what's going on, let me go ahead and reverse the image here. So I'm here, it's 12:18, it's 87 degrees, so already a little bit hotter. The trip meter here, this is Cinch charge of 0 miles, so odometer 23,308, and we'll check back in just a little bit. All right, so I thought I'd check in, hit the first real bit of traffic here as we cross from the 680 corridor over into the California Central Valley. So we are doing a whopping 20 miles an hour, kind of behind all this crud here, but this should clear up basically as soon as we enter the California Central Valley. So not a whole lot longer. Doing remarkably well on watt hours per mile. You can chalk a lot of this up to driving downhill for the first part, and then I suspect we've got just a little bit of a tailwind, although those windmills up there look like they're not moving a whole lot, but all of those gains should be reversed coming back home. So we'll keep an eye on this number for the basically our burn rate as we head in. All right, that's it for now. See ya. Thought this was cool. Here's the Tesla Semi that also Fax Chaser doesn't think exists, but it's crushing it, man. It's really cool. So good job for that guy driving his Frito truck. See ya, buddy. So I thought that was really cool. Just passed a Tesla Semi. He's cooking along doing the Frito-Lay thing. We're now 103 degrees and rising. So just crossed over the Altamont Pass into the California Central Valley. We're still on 580 here. Car's doing well. Still really good consumption. Again, I expect that to turn basically as soon as we start heading northbound due to both altitude and headwind changes. But car's doing great right now. So 87%. Forecasting that we'll be at the Starbucks here with 67%. I think that's going to tick down and probably level out at about 60. So anyway, looking really good. Smooth sailing from here. All right, talk to you soon. Thought I'd show this. We're just now to about Turlock, hitting 106 degrees. This is the highest temperature I've seen so far. Been pretty steadily over 100, or basically it's been 100 since about 5 minutes into the drive, but consumption's still really good. Again, I chalk a lot of that up to just hanging right in there with the speed limit. So not doing 75, just poking along at about 65 here in a 65. So still looking pretty good. Supposed to get to the Starbucks with 63%. See you soon. All right, I'm now at the Starbucks. I'm gonna go ahead and continue my trip home. 105 degrees out here in Merced. Really good burn rate on the way back, and we'll see how that goes. And I'll check in with you a little bit. All right, so checking in on the 99 again. 105 degrees out. We're just north of Merced. Consumption's still really good, so 217 watt hours per mile is outstanding. I'd largely chalk that up to this just kind of like ongoing traffic where, hey, even though I'm setting 65 in the speedometer, 60, 61, it's about all I've been able to do. So nice thing is it's projecting us to need to get back home with about 17-ish%, so we'll see how that holds, but still motoring along. All right, this will probably be my last video before I get home. Still trucking along here on 680, 100 degrees out. The burn rate, 238 watt hours per mile, continues to tick up. Looks like I'm going to get home with about 16%, which is better than I expected. So looks like the temperature hasn't had a huge impact, and I'll check in later. All right, the drive is all done here. Got home with 16%. This loosely translates into 49 miles. 97 degrees outside, and these are the big stats to keep an eye on. So 60 kilowatt hours used at an average run rate of 242 watt hours per mile, and that tracks pretty well with everything we were expecting to see. So a little better than basically right on it rated for the trip as a whole, from start to finish. You can see that we did a little bit better, and then at the turnaround point did a little worse, and I chalked that up largely just to the wind. So good result here. Surprisingly good result. So a little bit underreporting from the trip computer, but we'll take a look at on the big screen. All right, I'm back. So what are the results? When we look at the consumption, we did 246 miles and still had 16% remaining on the battery for a total battery consumption in percentage terms of 84%. I thought that was really good, better than I expected, in fact. So that's 60 kilowatt hours at 242 watt hours per mile, giving us a notional max range at 295 miles. And what are my conclusions? Well, I think this is definitive evidence that a long-range Model Y can travel farther than 160 miles on the highway at temperatures over 85 degrees. So we did have some things that went worse for us in the test and some things that went better. So I will caveat that the overall driving speed was less than I anticipated, and that's just a function of lots of traffic. I did this test at what I thought was the hottest part of the day, right around 2, 3, 4 o'clock. And in the Bay Area, that just means I hit rush hour. So I was driving on average a little slower on this trip, call it 60, maybe 65 miles an hour on highway speeds than I was on the last trip. And I think that's the reason for the reduced consumption as compared to the previous trip I did, which used 62% of the battery. But what I found really surprising was the temperatures were even higher than forecast. So this wasn't just 85. Average temperature on this trip was about 100 degrees. A little hotter in Modesto, a little cooler in Orinda. Average temperature was way up, though. So my conclusion there is that speed has a much, much bigger impact on range than temperature. In fact, the temperature impact was more or less negligible. I just really impressive result here, and hopefully this puts to bed any sort of delusion that you might have that an electric car, specifically a Tesla, is just crippled or somehow won't be able to go very far when the temperatures are high. And I'll close out with a sort of an op-ed outro here. Okay, so my op-ed outro. I had a little secret. My secret was I had a 2019 Model 3 long range, and I used to live in Reno, Nevada, and commute to Fallon, Nevada. I did that for a couple of years before the pandemic hit, and then I moved to California. During that time, the commute round trip was 160 miles. So on occasion, the temperature would drop below 10 degrees Fahrenheit, so single-digit temperatures, and sometimes in the summer would go above 105. I never had any problems going 160 miles. Typically, I would just charge to 80%, and sometimes I would come home with maybe as little as 20%, maybe as little as 10%. But I knew going into this that 125 miles and 160 miles were just ridiculous claims, which is why I challenged them. So my hope here is, hey, you know, if I sit back and say, all right, who won this this challenge, this online challenge from Facts Chaser? I'd argue that he won the battle, but hopefully we're winning the war. And what do I mean by that? Winning the battle means that that tweet, basically a total misinformation lie about what electric cars can do, cost this Facts Chaser guy 20 seconds of his time, versus this was nearly 10 hours of driving for me and video editing. And I'm not some YouTube guy who does video editing all the time. So this is a challenge for me. You know, I got to kind of figure out from square one what I'm doing here. So certainly he won the battle there, but hopefully the war, which is the war of misinformation. You know, we're now in an age where it doesn't cost anybody anything to lie. There is no consequence for this. But, you know, I'll sort of think back to, I remember I was reading a Sam Harris book. And one of the things that Sam Harris brought out was, hey, look, you know, if you take a look at all the religions that survived from sort of recorded history in mankind to present, all of the ones that could be easily disproven. So these are ones where, hey, there's a God that causes something to happen like the sunrise. Well, science is pretty capable of disproving that. The only religions to survive at this point are the ones that deal with the afterlife, because they're not provable, or you can't disprove that claims of grandeur or heaven or hell in the afterlife aren't true, because we have no way of proving those false. So my advice to the folks who want to besmirch Tesla or EVs or somehow say that this is not possible or feasible, is get better evidence, or basically make claims that are not yet disprovable. And I'll give you an example. So I've got a 2019 Model 3 long range and a 2022 Model Y long range. And I would say, look, we know a Toyota, a well cared for Toyota, can last over 20 years. And how do we know this? Well, there are Toyota cars from the 90s and early 2000s that are on the road today and doing just fine. So if you were going to make a claim against a Tesla, don't use something that any Joe Schmo like me can go out and disprove. I would recommend trying to find something that we don't know yet. I don't know that my 2019 Model 3 will last until 2039, or my 2022 Model Y will last until 2042. So just as a recommendation, that's a way better tactic is, don't attack something that I can go out and disprove on my own. Go out and try to make a claim against Tesla that is yet unknown. We don't know if the 2170 cells that are being put in the mass market Tesla vehicles are going to last 20, 30, 40 years. In fact, it's quite likely that they won't last 40 years, right? These things have a calendar life on them in addition to cycle life. So anyway, in closing, my big idea here is hopefully this disproves that Facts Chaser is to be trusted. Like, I'm going to link James Stevenson on this. It was ironic. He did a video on this very subject today, which is the trustworthiness of some of these accounts. And clearly this guy is just out to, sort of drag Tesla's name through the mud, but used a really poor example to do so, something that could be easily disproven. So I hope in the future, do better work, man. But in the meantime, thanks everybody for watching. You got an idea for a video, something else that needs to be disproven, I'm all ears. Anyway, take care.